All right, we've looked at how to predict if something will precipitate out a solution or if it will be aqueous. We've talked about what a precipitation reaction is. Now we want to look at predicting what will happen in a double displacement reaction. That is, predicting what the products will be from the reactants and if those products will be aqueous or solid. So let's look at this problem here. What would happen if we mix aqueous silver nitrate with aqueous sodium chloride? And the first thing we probably want to do is look at what this would be in solution. And since something is aqueous, that means it would really, if it was in solution, be these silver cations and these nitrate anions. And we'd be adding it to these sodium cations and these chloride anions. So that's what we'd really have floating around in solution. And in a double displacement reaction, what happens are the cations and anions switch partners. So here, the silver cations were with the nitrate, and now they're going to be with the chloride, and these sodium were with the chloride, and now they're going to be with the nitrate. So our possible products that could come out of this would be our Ag would now be with our Cl. We have a +1 charge and a -1, so those go together 1 to 1. And then the other possible product would be the sodium is now with the nitrate. And we would have our NO3 would be our other product. So if we took our AgNO3 aqueous and we added it to our sodium chloride that was also aqueous, these are the potential products we could make. And now we need to look and determine if we think those would be solids or they'd be aqueous. So to do that, what you need is your chart here on predicting if something will be a precipitate. And if we look at our rules, we're trying to determine if silver chloride is going to be solid or aqueous. So we look and we find that halides tend to be soluble, but an exception is for silver +1. So we'd expect this to be solid, right? And then we want to see if there are any rules about sodium cations and nitrate. And in our first box, it says group 1 metals tend to be soluble, so sodium is in group 1. And it also tells us that nitrates tend to be soluble, so we'd expect this to be aqueous. And there are no exceptions there, right? And if we wanted to kind of look at what's going on, right, then it turns out that our real reaction is that we have Ag plus aqueous plus Cl minus aqueous going to AgCl solid, and both the sodium here and the nitrate are spectator ions because they're aqueous on both sides of the equation. So they're not taking part in the chemical reaction. So again, those were our spectator ions. And the net Ionic equation would just be this bottom equation here. So let's try another one, because you'll need to be able to predict the products of a double displacement reaction. So what would happen, for example, if we took barium chloride aqueous and we added to sodium sulfate 4. What would be our potential products of a double displacement reaction here? And once again, if we break it apart into the ions, because it's aqueous, what we'd have in solution is we'd have barium cations, and then there's 2 chlorine here, so 2 chlorides. And then we have 2 sodium, so we'd have 2 Na plus aqueous, and then we'd have 1 sulfate polyatomic ion here. And again, when predicting the products of double displacement reaction, the cations are going to switch to be with the other anion. So this barium now is going to want to be with the sulfate, and this sodium is going to want to be with the chlorine here. So your potential products are, now you have barium And barium has a +2 charge, sulfate has a -2, so those will go together 1 to 1, and the other combination of sodium is going to be with the chlorine. So you'd have 2 NaCl's, and then the trick would be predicting the states of matter of the two things produced to see if we actually get a precipitate coming out or if everything just remains in solution. Right? And so again, you'll need your chart on predicting precipitation to determine if these products are going to be soluble or aqueous, and hopefully none of you need to use that chart to determine if sodium chloride is going to be aqueous or solid. But if we were going to use it, we would look for rules on sodium and chlorine or chloride. Group 1 metals tend to be soluble, so that's sodium, and halides tend to be soluble, so that's chlorine. So we know that salt is aqueous, and then we're going to look at our other product, which is barium sulfate, and look for rules on barium or sulfate. And our chart tells us sulfates tend to be soluble, but if we look at the exceptions, there's an exception for barium 2+, so we'd expect that to be a solid. So our overall net ionic equation is we just have our barium, and we're adding it to our S sulfate, aqueous, and we're getting solid barium sulfate. So again, our spectator ions here, our sodium is not doing anything, and our chlorine are not doing anything. This is the net ionic equation.